Alrighty, so today we're working on 7.2 from Systems of Equations, and today we're going to start finding solutions to our systems. The first way we're going to do it today is graphically. So a solution to a system of linear equations is values for x and y that are true for all equations. Are true for all equations. Now in this case, it's going to be an x and y value, and it will be, where do your lines intersect? Where do the lines intersect? As in, where do they cross each other? Where do they agree on a point? Now in the future, we won't always have an x and a y value for a solution, but in this case we do. So where do our lines intersect? So today we're doing it graphically. We're going to see where do our lines cross each other. Find the solution for the linear system and verify that your solution is correct. So on a graph, it's actually really easy to tell. It's just, where do your two lines cross each other? I'm going to put a big dot on my graph right there. That's where my two lines cross each other. And I'm going to state my solution really obviously over here. I'm going to use my red pen to state it super obviously. X is -1, because we're 1 to the left, and y is +2. That is my solution. Done. They also asked me to verify that my solution is correct, so I'm going to do that over here. What we're going to do is we're going to double check that this point works for each of these two equations. So I'm going to write down the equation, substitute this point in, and just double check that it still works. If it doesn't work, then something has gone wrong, and that is not a solution. So I'm going to substitute this point into my equation. 2, the x value is -1, minus the y value, which was 2. And let's see if this left-hand side equals -4. If it doesn't, then this is not a solution. Hopefully it does, which I think we're good. Check mark. This is me verifying. So I'm kind of putting it back into the equation to just double check it. I'm gonna do it the other side too, because if it, or the other equation as well, because if it doesn't work there, then it's not a solution. It has to work on every single equation. If it does not work in every single equation, then it's not a solution. Kind of ran out of space here. Oops, made a mistake here. Sorry, -3. I was thinking, oh shoot, that doesn't work. Okay, there we go. So this stuff on the left does equal -1. So this equation is correct for this point. Therefore, this is a solution. Let's try another one here. Determine the system of equations represented by the graph. Determine the point of intersection and verify that your solution is correct. Okay, so determine the system of equations. We have to come up with a system is just more than one equation at a time. So determine the equations that make up these lines here. Then determine the intersection and then verify. This is 3 things. It's actually a lot of things to do in one question, but let's give it a shot here. I'm going to call this equation A and this one B, just so I can kind of keep my stuff organized here. So starting off with A here, I need to come up with an equation for this line. So I see that it has a really nice y-intercept. So I'm going to use slope-intercept form because I think that's the easiest. So I can tell that my y-intercept is 5 right there. And I can also tell that my slope is 1 over 1. So it keeps going up 1 over 1. So y equals 1x plus 5. Just don't bother writing down the 1. Now my b equation, let's see, this one also has a really nice y-intercept at -1. And I think this slope is down 1 to the right one, down right to the right one. So y equals -1 plus 1. That's a plus 1. Okay, so there's my 2 equations. That is step number 1. That's question number 1 there. Question number 2 is determine the point of intersection. So I have to kind of state the solution here. I'm going to state it really obviously. I'm going to put it over here. So this is question number 2. The x part of this point is -2. The y part of this point is 3. This is my solution for this system of equations. And then finally, it asked me to verify. So this is like the third part of the question. I'm going to verify in each of these equations that this solution works. And if it doesn't, then something has gone wrong somewhere and I need to double check it. So I'm going to start with A. I'm going to substitute into this equation, and hopefully the left-hand side equals the right-hand side. So y is 3, x is -2 plus 5. Let's just simplify this a little bit. 3 equals 3? Yes. So far we're good. Let's try in the other equation. So this is my b equation. Y equals 3, -2 plus 1. Negative is positive. So 3 equals 3? Yes, it does. Now in this case, we both had 3's at the end, but that part doesn't matter. It's really, does the left-hand side equal the right-hand side, and does the left-hand side equal the right-hand side? If it does, then we're good to go. So I verified it. This is the solution for this system. We're good. Pause if you need to, but I'm going to keep going. Solve this linear system by graphing. So this time we are not given a graph, we have to graph it. I'm going to call this equation A and equation B, just again so I can kind of label things. This is called standard form, and standard form is not really that easy to graph from. So personally, I'm going to change this to slope-intercept form, because I like that one the best. You can change it any form you want. Or you could just find x-intercept and y-intercept, or any other point and graph it that way. There's lots of ways to do this, right? Now, slope-intercept form has y equals everything else. So I'm going to get y by itself on the left-hand side. So I'm going to subtract 2x from both sides. And then it's just y. So I'm going to divide both sides by 3. And there we go. I can graph that pretty easily. So the y-intercept is 1. And then my slope is -2/3. So I'm going to go down 2 and to the right 3. And particularly with these questions, I like to do a couple of points in both directions, and that way my graph is really perfect. Because if you're going to solve this by graphing and your graph isn't perfect, you're going to have a tough time. So I went to the right here. I'm going to also go to the left. So I'm going to go up 2 and to the right 3, or left 3, up 2, left 3. And you can see how that continues the pattern. Definitely use a ruler when we're doing this. Because again, if it's not perfect, it's going to be difficult. Of course, we need arrows and we need a label, and I'm going to label this with the original equation. But if you use the equation that you put, that's good too. Any equation that describes it. Now I'm going to do my B equation. I'll just do it in red so it looks different. Again, I would prefer if this was in slope-intercept form, so that way I can graph it a little bit easier. So again, I'm going to try and make it look like this. So I'm going to put everything, keep y over here and put everything else on the right-hand side. And then I really need this to just say y. So I'm going to multiply everything by -1, basically change the sign of everything. And there we go. We're in slope-intercept form. My y-intercept is -4. My slope is 1. So -4 is my y-intercept, and slope is 1/1. And you can see where my intersection is going to be right there, kind of passed over it. Let's finish off our graph. We do still need to make our graph as beautiful as we can. So arrows, label. Last step here, this is really quick, but our very last step is we have to actually state our solution. We have to say it, because we're not done and we haven't solved it until we say what our solution is. Our solution is right at that point here, 3, -1. I'm gonna put a big box around it, really obvious. Maybe I'm gonna even state it down here as well. Big box around it, make it really obvious that this is my solution. Because you're not done solving until you actually have a solution, right? Let's do one more together here, and then it's time for some practice. So again, I'm gonna go right into slope-intercept form. So get everything to one side. Slope-intercept form is my easiest form to graph from. And then go ahead and do it. And again, when I graph, I put more than a couple points, right? Just to make sure this is perfectly graphed. Because if it's not, then it's really hard to tell where do your two lines intersect if your line is a little off. Okay, try this one right here. These ones are a little bit easier to put into slope-intercept form, which is nice. I should have put that in red, but that's okay. Okay, and wherever our two lines cross each other, that is our solution. And I can see it right there. It's at 2, 2. I'm just going to state it down here really obviously. 2, 2. I do put brackets around it because this is a point. It's not just two random numbers, right? It is a point. We could verify this point by putting it back into each of these equations. And when I verify, I typically use the original, just in case I made some mistakes somewhere. So I go back to the original equation to verify, but then you're done. Thank you.